Hey guys, what's up? Good to see you again. Yeah, it's me again. But I'm not going to talk to you this time. Thank you. I'm not going to talk to you about health this time. I'm going to talk to you about what I used to do, what I spent many years doing. I don't even know where to begin. I was in the military for 6 years and I worked on electronics. So, anything that's inside stuff like this, anything that's inside of a radar, communications, satellites, all that stuff I worked on. That's how I started my journey in the year 2000, working with electricity, with electronics. I got out of the Navy after 6 years, and then I did construction with my dad for about 6 years. We ran a company, did a lot of stuff, don't want to bore you. And then after that, while I was in the Navy, I started my bachelor's degree in electrical engineering. And so I finished my electrical engineering when I got out of the Navy in Tucson at the University of Arizona. So I am a BS, which is, it's not BS like what we think, it's Bachelor of Science, double E. And so after that, while I was in college, I was sent to Paonia, Colorado. Anybody know where that's at? It's a beautiful place. The journey there is beautiful. And they have a training there for through a company. I'll show you, well, I don't have a projector, but I'll show you in a little bit. Solar Energy International. And I went there to do training for solar because I was doing solar classes in Tucson. And so that's where I first really was exposed to hands-on, going out to different farmers and installing actual solar systems and well pumps for their cattle, for their little gardens, for whatever. And I was fascinated with solar. I'm still a little fascinated, but I've kind of moved on. And so then, I moved to Farmington because I got a job at the airport working for the government, for the FAA. So I got kind of tired of it, and so that's why I moved to Oregon, because I got accepted into medical school. But anyways, I'm going to talk to you today about, what is this? Oh, I'm sorry. What is this? What is it? She said a hose. It's a tube? Yeah. What is it supposed to be used for? Wires? Water. Yeah. Where would you buy such a contraption? Why would you want to buy such a contraption? Transfer water. Why? What? You said something, come on. Yeah, it's for transferring water, right? So it's to get water from one point to another. This is made out of poly. Okay, we call it's basically a polyethylene-based plastic. It's very thin-walled. This isn't the kind of stuff you use to set up your house. Okay, so don't buy this stuff. Just because it's cheap, don't buy it to set it up for your house. Buy the other stuff that's got thicker walled. It's called PEX. They come in either like a light white or a red or a blue. But this stuff, this is half-inch stuff, and you can hook this thing up to pumps. There's a 3/4 inch line over on the other side of this building, but this is half-inch. And I had the guys bring stuff in for me, and I'm not even sure where they are. Do you remember where that pump went? Let me see here. I think it's back here. Oops. No, that pump, it's like a silver-colored, stainless steel looking. By the door. Can someone, oh yeah, that. Can you bring it over here? Thank you. Thank you very much. So, this right here, I already told you, is what? What does it pump? Irrigation water? It'll pump any kind of water. Any kind of liquid, really, as long as the viscosity is right. Now, this pump right here is a very inexpensive pump. I showed this pump to some of you last year who were here. This is a very inexpensive pump. And with this pump, it says it's a submersible pump, okay? Submersible meaning you can immerse it completely in water and you won't get electrocuted. It doesn't make sense, right? So why would you want to do that? Well, because you want to pump water from point A to point B. So with this kind of pump, you can literally, you see this outlet here? You can literally hook up a pipe like this to this outlet right there. And all you got to do is put a tie right here and tie it really tight, okay? And then you can pump water. Now, we have this pump over here that also does the same thing, okay? I don't know if you can see it. You can kind of see it, right? Maybe. Can you see it? Most of you? So this pump is also a pump. So I'm going to ask, what is the difference between this pump and this pump? Pardon? Say again? That is true. This one cannot go underwater. This one is not even a horsepower. But they serve different functions. Okay? For one, this is an electric pump. It runs on electricity. This is a gas-powered pump. Now, if you have, I don't know, sheep, cattle, or crops, and you live very remotely, far away from anything where there's any main water source, which one of these would be more beneficial, more practical? This one, right? Why? Because you put gasoline in it, and you walk away, and it'll just keep pumping water. But what happens when the gasoline runs out? Oh man, I gotta run back into town, right? What about this one? You can plug this into a house, sure. You would need a AC to DC converter. But even better, if you were out in the middle of the field and your house was like, you know, from here to like, I don't know, that neighbor's house way over there, you know how much wire you would need just for this? And then you'd be running over it. The cattle might chew it thinking it's grass. I don't know, I'm just saying. But not the cattle, but probably the prairie dogs, because they have done it here, okay? They will chew through this. So you have this pump. It runs on DC. So here's where we're going to get into electricity. What is DC? Some of you might know that this is just basic stuff. I'm not going to get into any complicated stuff. Direct current. What is, can I plug this directly to the wall? You're right, I can't. Why not? Because it's DC, yes. So let me, I'm going to draw you a diagram. And I didn't bring an eraser, but I have my trusty little glove that I'll use as an eraser. See? So I'm just going to give you an illustration on what the differences are between AC and DC. So whenever you plug anything like CenturyLink router, this cooler, your phone charger, whenever you plug anything into the wall, like someone's charging their phone right now, see? Let's see here. I think you missed a call. Anyways, you plug anything into the wall, it's 120 volts AC. That is the electricity coming out of the wall. It never changes. It's always the same. That's how it's coming from the power company, okay? This phone, sorry, whoever this belongs to, but this phone also runs on DC. But you have this trusty little charger right here. What is this? What's inside of this? Huh? Yeah. What'd you say, Lucian? Okay, so there it is. Safe. Now, I'm going to draw you this diagram. So I'm going to draw a line, vertical line, and then I'm going to draw you a straight line, okay? You see this? Looks like a sideways T, right? So I'm going to draw you two illustrations. for the sake of simplicity, I'm going to make this line 0, okay? This is 0. Is 0 anything? No, right? If I told you, I want you to touch, here's a live wire. It's got 0 volts. Would you touch it? Would you? Zero volts. Nothing. Okay? There's nothing there. Do you get it? Okay. Now, don't be afraid of electricity. Electricity is our friend. It is. It really is. It's here to help us. To help us in many things. So, 0 volts, right? Let me do that again. 0 volts. Okay? V for volts. Okay? See that? Now, this stuff coming out of the wall looks like this. That's how it looks like. Okay? And up here, this point right here, okay, this point is 120 volts AC. Theoretically, it's RMS. Okay, root mean squared. In theory, it's actually quite a lot more than 120 volts. It's closer to 180, but we're using RMS because that gives us the rough average of what you actually see in work. So 120 volts, basically from this point to this point. Okay? I'm sorry, it's more than that, but it's 120 volts from here to here, and then also from here to here, negative and positive. Okay? So in reality, this is around 380 something volts or more. I'm forgetting the exact numbers. I know it sounds weird, but that's how we name it. We just name it this way to keep it simple. Okay? Now, when you have this voltage, it goes up, and then it comes down, and then it goes up, and then it goes down. So we call it a sine wave, right? Because it's literally a sine wave. Makes sense, right? It's pretty easy. This is really easy stuff. Once you see it, you understand it, you're like, you get paid all that money just to know this? Like, yeah, actually you do. But there's a lot of math involved. So if you can, anyways, so we call it volts AC because the AC stands for alternating current. Okay, it alternates from positive to negative, and then back to positive, and back to negative, and it just dances all day long. Right? And it does this dance at a certain rate. What do I mean by rate? It does it so many times a second. And that rate is 60 hertz, or 60 up and downs. So this is 1 hertz. Okay? 1 cycle going positive and then negative and then back to 0, that's considered 1 revolution, 1 cycle, 1 frequency, 1 hertz. It's all the same. That power coming from the wall is doing that 60 times in 1 second. It's pretty fast, right? So what about DC? What is DC doing? How is DC different from that? Well, with DC, okay, for instance, I'll give you an example. This pump here, it says, what does it say right there?
24 volts.
24 volts. 24 volts. Is that a lot? DC looks like this. It's kind of boring, isn't it? DC doesn't like to dance. DC's like, eh. DC is either positive, in this case, so this would be positive. This would be positive, and this down here is negative. Okay? DC can be positive or it can be negative. Okay? We use things like this. Oops. We use things like this to measure voltage. Okay? Okay? We use things like this to measure current and voltage. Clamp meter. Okay? You put it around a wire, and it'll tell you the voltage, and it will also tell you how much current is going through it. Does that make sense? So, it's important to know both. Okay. What do you see? Can you see it? What does it say? Huh? It's 120.7, 121.4. It's fluctuating a little bit, and it depends on how much power people are using in this area and how far away from the transformer you are. That will depend on how much voltage drop you have. So look at this. Here's a little yellow button. I'm going to push the button. What do you see now? 60.00, right? Is that what it says, Jared? Oops, it came off. But you saw that, right? So this thing will tell you your volts in both AC and DC. If I were to do DC on this, if I were to switch this to DC, it would read 0 coming out of the wall. Okay? So we use things like this to measure stuff like that because it's important to know what we're working with. Now, DC, whether it's positive or negative, is just positive or just negative. Okay? It will never be anything different. And I could say a bunch of other stuff to confuse you, but this is just the basics. So now, I want to tell you about something else. There's this book. This is maybe a little more advanced for you, but I want to, for some of you that don't plan on maybe going to college, that maybe want to get into a trade, a very well-paying and a very good trade to get into is to become an electrician. Okay? You'll get a book like this and many others, but this is basically a reference. It's like a pocket guide. It's ugly. It's literally uglies. Okay? That's the name of the book. And in this book, you find all kinds of crazy formulas and wiring diagrams and voltage drop and transformer setup and windings and, just different stuff. And so this book on the front, the reason I got it is because I wanted to show you something. On the front cover of this book, you have this little circular thing. You see it? It's very neat. From the moment that I first started my career in electricity, I was shown this diagram. Okay? You know what we call this? Maybe some of you know. You ever seen it before? Pardon? It looks like what? Looks like pie, right? It looks like a pie. Well, it does to us electricians, electronics people. We call this the pie chart. Pretty stupid, right? But that's what it is. So you have to do stuff like that to make it simple. And so in this chart, the reason this chart is fun is because you can always go back to this to help you figure stuff out. This is what we call Ohm's law, okay, simplified. Ohm's law just tells us how to figure out current, power, voltage. Remember, she mentioned, oh, this one's 7 horsepower, right? And then I said, this one's not even a horsepower. How did I know that? It doesn't say, does it say how much horsepower is on this? Does it? You tell me. Just look at it until you find it. So, she's shaking her head. So, it doesn't say. Because what is horsepower? Pardon? Say again? Horsepower is a unit of measure that we use to tell us how much work, whatever it is we're talking about, can do. So, would you rather have if you're in a race, would you rather have a Dodge Viper or would you rather have a Toyota Corolla? He said a Corolla. Okay, let's step it up a notch. Would you rather have a a McLaren F1 or a Geo Metro? If Moses was here, the other Moses, he would beg to differ. He would want the Geo. But so what I'm trying to tell you is, why would you want the other car, the faster car? What makes that car faster? It has horsepower. And you know, unfortunately, these vehicles also possess another unit of measure that we never talk about, and that is torque. Okay, torque is true force. Horsepower is work. I don't know, I don't want to confuse you. But anyways, so horsepower is what tells you how much power, how much work this car can do, right? So you can convert horsepower into watts and vice versa. This thing is, it doesn't even tell me the wattage that it's rated for. It tells me 24 volts, okay? Basically, I'm just going to make it simple. So P equals I V. Not this IV, the kind you go when you're at the hospital. What does I stand for? What does I stand for? Okay, so P stands for what? Power, yes. What does I stand for? Internal? Intern? How is that useful to us? Intake? This is stupid, but this is how they did it, okay? Don't ask me why. It stands for current. Actually, it does have a meaning, but I'm not going to get into it because it's more complicated than it really matters. But I stands for current, okay? And V stands for what? Volts. Now, what does that mean? I told you what power is. What is current and what is voltage? What's the difference? I don't care. Just plug it in. Plug it in, plug it in. Remember that commercial? She does. Okay. Power, current, volts. I'm going to erase this. You guys get this concept? Right? Where's... Okay. Okay. So, I'm going to try to explain to you what current is and what voltage is in the most simplest way, okay? So, voltage, what did I do with those markers? So, voltage is basically electromotive force. Whatever. Equals EMF. Who cares? What it really means, it's just potential. This is kind of the word that, you know, voltage. Voltage is potential. Like you all, especially you that are younger, You have great potential within inside of you. You have great potential to do many great things. It is up to you to choose how you want to channel that potential and apply it into something meaningful in your life. Or you can use that potential to do something extremely stupid in your life. You understand what I mean? It's just like the voltage in this wall, it can be used to power this router or to power this phone so you can call your grandma or your Nolly or whatever. Or you can use it to stick your finger in there and kill you. Right? Do you understand what I'm saying? The potential will be used depending on how you choose to use it. It's the same with us. How you choose to use the potential that is within you will vary the outcome that will result. Do you understand what I mean? So potential just tells you how much of it do you have. Like for instance, you put a skinny guy, scrawny guy, and you put a very buff dude like Arnold Schwarzenegger back in his prime. And you're like, I want you to lift up, this boulder right here. Who do you think is going to be able to lift it up? Arnold? Why? Because he's got muscles, right? He has more potential, right? He's got more muscles. Does that kind of make sense? That's a stupid analogy, but I'm trying to give you an idea, a concept. So voltage, think about it as potential. So 120 volts, I know it's AC, or 24 volts, like this pump. If you had 120 volts or 24 volts, which one has more potential? 120, it's obvious, right? Because you have more of it. So the more voltage, the more potential. So like this voltage coming out of the wall, it's 120. When you go to that transformer right there on the street, on the pole, you see it? That's a transformer. It's hanging on that pole out there. And it's got 3 wires coming out of it. One of them is kind of like a ground. It's coming from the tension wire. Oh, sorry, lady. It's coming from the tension line. The other one is, and the other 2 are voltage. You know that up there, that line that's coming from the power company, it's actually a lot higher than 120 volts. Depending on the utility, how they set it up, it could be from anywhere from 2,500 to 7,200 to even 13,000 volts. Okay? It's pretty high. In some places, it's even 25,000, but those are the really high ones, or even higher. Okay? So you have transformers, those things up there, because what those things do is you have power going in, and you have a coil, and you have power going out. So what happens when you wind up wire in a coil, you have a field of electricity, almost like magic. It's like invisible stuff, right? And it literally just shoots out like a radio wave, okay? That's why they call it an electromotive force or potential. Now, this thing shoots out from this. It does it from a wire, but it does it even more when you wind it up. Okay, that's called impedance. So what you do is you can put another wire next to it, and it will absorb that electricity, and it will create an electricity flow. So if this is going this direction, the electricity will go the other direction. Okay? It will create a flow, and it will be inversely proportional to the amount of electricity that's flowing through here. Now, that doesn't matter. So when you coil it up, if it was an even coil, like this one, if it was exactly like this one, and you had, say, 7,200 volts on this side, you would also have 7,200 on the other side. Do you believe me? Well, you do. Now, if I cut this in half, and it's only going, does it make sense to say that it would only be half of this? And so you can change the winding, is what we call it. You can change the winding to get the voltage you want. And that's how we do, like even this. This is a AC to DC converter, just like her phone. But she took it. So whoever it was, the phone turns 120 volts AC, and it converts it by using something like this on a small scale to 5 volts DC. So it's far more complicated. You have a bridge rectifier with diodes, and they go up, and you have another one here, and you have another one here, and you have another one there. You have another one there. And then you got a whole bunch of other circuits, resistors, transistors, and stuff like that. But in a nutshell, the transformer is what's doing the stepping up and stepping down. All this does is it converts this into this. Okay? Don't worry about this. I'm just giving you an idea of how electricity works. So, going back to voltage. Voltage is like if you had a water tower full of water. Okay, you have a water tank with, say, I don't know, 100 gallons of water. Maybe it's green water, okay? And it's 100 gallons. And, okay, and you have the ground, and you have a little tiny dude down here looking up. And then you have another water tower. Okay, maybe you've seen those kind. Okay, and this one has, I don't know, 1,000 gallons. Maybe more, whatever, it doesn't matter. And then you have another little dude over here. And he's like, wow, right? He's excited because he just saw a big water tank. So this water tank, compared to this one, it has more water in it, right? Which one has more potential? This one, right? I did an illustration with my son trying to explain this to him, like a couple months back. If I put this little line here, see how tiny this thing is? If I hook this up to this thing, right? Little tiny little line down here, okay? And it goes down here, right? Now, on this one, I put a massive line. A line, say, the size of this diameter. Which one will give me more water? Faster. The one on the left, right? Why? Because the pipe is bigger. It makes sense. It's easy to comprehend. This side, it would take a long time. But this side still has higher voltage. So think about the water coming through at the speed that it's coming through as current. How much current is coming through? Okay? Does that make sense? And think about the capacity of it as voltage, the potential. Okay? And then I can get more into it. I can get into the physics, like how many feet, how much PSI is built up depending on how high the water tank is. And that all kind of factors in too on how fast this water would come out. But anyways, that's going overkill. Does anyone have any questions about this? Okay. Now, I asked you earlier, 24 volts. How do I know how much horsepower this has? I already told you the formula. Power equals current times volts. Well, this tells me here that it says 24 volts and 5 amps. That's the rated capacity of this pump. Okay? So see that? It's just simple math. Anybody have a calculator? Can you multiply 24 times 5? What is it? $120, right? $120 what? Watts. Okay? It's that simple. Now, how many watts are in a horsepower. Yes, you're right. 1 horsepower equals 746. Some say 747. Whatever, it doesn't matter. Watts. So, if you were to do that at this conversion factor, how many horsepower is this pump? How many horsepower is it? 0? Are you sure? .16. Okay? So, our little pump here, this little guy, suddenly doesn't seem like such a mighty beast, does he? It's a 9-pound weakling. So this equals 0.16 horsepower. So then, why on earth would I want to use that when I could just use this? Those are all very valid points. This one uses fuel, and it causes pollution. Uses a finite resource, and I don't know, you just got to deal with putting gas in it. And sometimes, you know, how long do you think this pump is going to last?
12 years.
I don't know. It says here that you can run it 2.5 hours on a tank of gas. Probably get a lot of fuel or a lot of water out of it. So I'm not saying this is any better or any worse than this. That's not what I'm here to tell you. I'm not here to say electricity only. I'm not one of those Greenpeace people. But I do believe that we need to do what we can to mitigate the pollution that we're creating. That's why we fought hard to shut down these power plants, because they were causing a lot of pollution in this entire valley. It used to be that you can look at the maps, aerial maps of this country, on the EPA's website, and they would tell you what are the most polluted areas. And Farmington was usually in the top 5 because of these 2 power plants, because of, pardon? Yes, but I'm talking about the Farmington area as a whole. And because there's also another power plant over there, somewhere, Aztec, Farmington, I don't remember where it is. But and that's not the only thing. You have a coal plant, you have all the oil field work going on here. So you have a lot of things contributing to this pollution. So we as a people need to do more to protect the land that we have, right? I meant to tell you this in class the other day, and I didn't. I did a study when I was going to school here, and I presented it, and it was on the contamination of the leftover uranium mine that's in Shiprock. You know the Tillings field that's out there? Or the tailings. So there is still a big landfill, basically, of uranium. I don't even know how to explain it to you. If you're going to Shiprock, it's on the left, right, before you get to the bridge. And it's contaminated all of your groundwater. You can't even drink the water in Shiprock because it's so contaminated. I mean, the groundwater. So you couldn't dig a well and dig it. You could only pull it out of the river and filter it and stuff like that. That's your safest bet. And I think that's what NTUA does. But, oh, okay. Well, they pump it from Farmington, and Farmington gets it from the river and cleans it. So either way, what are the advantages of using this? And that's what I'm here to talk to you about. Well, portability is one of them, yes, but what else? I don't know what I did with my markers, but. So, yeah, okay, so this pump is going to cost you, I don't even know what this costs. Anna's not here, but it'll cost you whatever it costs you. You can get a cheap one at Harbor Freight, and you can use whatever pump they give you, but it's not going to last you very long. Okay, I don't know what this costs. Or you can buy a more expensive one, but the more expensive, the better the brand, the longer it'll last, right? Now, here's the advantage is, let's just say, I don't know, maybe none of you, but how many of you, maybe even in your families, herd sheep? Or have herd sheep? Or have, whatever. It's one of those things that is so like a part of your culture, right? Cattle ranching, sheep herding, okay, even just having a little farm. Like I remember being in Monument Valley and going out, like to Mystery Valley or whatever, and there's people farming right next to the canyon, and I'm like, how do they get the water? And they were like, yeah, there used to be a lot more water here, but there's no more water. So they don't know what to do anymore, right? And they're like, yeah, we used to have like, my grandfather used to have like 100 sheep, 200 sheep, whatever, I don't know. And we had to get rid of most of them. We only have like 5 or 10, because there's no water, there's no food, right? So what's a solution? Would this be a solution? Where are they going to get the water to pump at this? Because this thing, you know how much water this pumps? It'll tell you. It should. It doesn't say. That's usually the pumps will tell you how much water they will pump. And this one doesn't. But I'm sure this pumps, oh, it's right here. 16,000 gallons per hour. That's a lot. Okay. This is a good idea. I'm glad I thought about this. So, man, where's that other marker? I don't like these. Okay, so I'm going to just give you an idea. You have the ground right here, right? And you have little tree. Okay? Okay, so what we do is you dig a well into the dirt, okay? To get to the water that's under the earth, okay? It doesn't take much to do that. You have a bunch of little sheep, I'm not a good artist, so, those are my sheep. And then you have a sheep herder right here. I don't know, whatever. I suck at drawing, you can tell. But, so, you have a bunch of sheep, and you have no water. So what do? You can drill a well. Maybe you know of someone who has a well. Maybe there's an artesian well. Maybe there's spring water coming somewhere. Drilling a well is not that hard. If you do it right, it won't cost you that much money. I know you got to get approval from the tribe, from Window Rock, but it's not hard to do. I know people that have done it here on the res, in Page, in the Coppermine chapter, in Monument Valley. It just depends where you are because there's uranium contamination here in this area. Okay, you have to know the area and you have to have someone that'll at least guide you and tell you the water table in this area is okay, but over here it's not because they're usually divided, right? We call them aquifers. So there's a lady that lives out in Oak Springs and her water is safe and she actually has a spring of water coming out. It's very, very, very little. So here's the problem. When you use something like this that pumps 16,000 gallons an hour, that thing, you're going to pump a ton of water out of it, but at the same time, your water table is going to go down. Do you understand what I mean by that? It's going to go down because you're pumping all this water with this pump, right? So what you do, what happens is you have what's called a refresh rate. You probably can't even read that because my spelling sucks too. The refresh rates determines how fast the water comes back. That refresh rate could be minutes, it could be hours, it could be days, it could be weeks, it could be months. You don't know that. You figure that out when you first dig the well. Okay? So in the case of this lady, she's fortunate to have a spring that's pumping water out naturally, but it's so minimal. If I put this in there, it's useless because it's going to pump all that water in like 2 seconds, maybe 5 seconds, and then it's all gone because it's pumping way too fast. Okay? The advantage of something like this is that it's pumping very slowly. Okay? And it's going to pump slowly all day long. So in the case of this sheep herder, what we could do for this guy is we could basically put a tank. It doesn't have to be very big. It could be, you've probably seen them, a holding tank for, you put water in it for animals, for cattle, sheep, whatever. You know what I'm talking about, right? You put a tank right next to the well or to the spring. You put a little pump like this, and you hook it up, and you put a little solar panel. Well, maybe I'll dry it a different color. Whatever. You put a little solar panel. Okay? It sucks. Whatever. So you put a little solar panel and you have this pump down here. Okay? Pumping water. Yeah, it's pumping slow. But look at this. This thing will pump 3.2 gallons per minute. And you can buy bigger ones. Okay? 3.2 gallons a minute is not that much, right? If you were to do, where's my phone? Okay, so if you have a tank next to the well, about how many gallons does a tank hold? Depends on the size of the tank, right? Let's just say, I don't know, 50 gallons is kind of small. That's, 50-gallon drum. I'm talking about a tank, one of those water holding tanks. Usually hold 300 to 500, depending on the size that you buy. Okay, so you have 300 to 500. How long would it take to? Let's just say 500. How long would it take to get that thing full? No, not 3 days. Remember, it's pumping 3.2 gallons a minute. It would take 156 minutes to fill that 500-gallon tank. How long is that? 2.6 hours. Okay? You know what the nice thing about this thing is? It's going to fill up that tank. You can put a little valve on the inside, kind of like your toilet. When the toilet thing fills up, it cuts the water off, right? You hear the toilet filling with water, and then it stops, right? You know what I'm talking about? Have you ever heard that? So, same thing. You can put a water valve, a float valve, inside the tank, and when it's full, it will turn the pump off, and it will cut off the power on its own. In other words, you know what? I want to go down to Phoenix, or I want to go down to Denver, or hey, let's go to Oregon. Let's go visit Moses. Oh, but who's going to water the sheep? Forget it. It's on a well pump. We don't need to. Do you see what I'm saying? Now you don't have to worry about it. You don't have to worry about hauling fuel. You don't have to worry about, maybe this tank stopped working. These things are so reliable. They're so efficient. So it's about making life simpler. So the same thing can be applied. You can put a different, a big tank, like that green, have you seen that green tank that's out there by the greenhouse? That's a 2,600-gallon tank. It's pretty big, right? And if you wanted any kind of pressure, you could even, maybe even find a little hill somewhere and put the tank on top of it. Now you have even more pressure. Whatever, because you can put this hose and you can route it. Because this pump can pump up to a certain amount of height, okay? So you can fill this thing up with water, 2,600 gallons, and then you have water that you can use similarly. You can use it in a garden. You could use it at your house. You could use it wherever. Because see, that pump, if you set this up at higher elevation, and you want to set up a little homestead, or a little, what do you call it, cha'o, a little shade house, or a hogan, whatever. And you put this tank up And suddenly you have water. And you can use the same water to irrigate your sheep, or to give water to your sheep, or for a little plot of garden. You can plant your own produce. You see what I'm saying? So, all with this little pump. This little pump is cheap. I mean, you can buy expensive pumps like this, which I would recommend, or you can buy a cheap pump like this. This is about 370 bucks. Well, affordable is probably a better term. Yes, thank you. My audience is definitely listening. So, affordable. So, you can get an affordable pump, but this pump will not last you as long as some of the more expensive. I would recommend buying like the $700 version of this exact pump. Why? Because it will last you forever. Also, the other thing, you can kind of do it with this one too. The other one is easier. That pump, it comes apart, and you can rebuild them yourself. You don't have to hire anybody. You don't have to go to Basin Pump or whatever. You don't have to go to Esco Supply. You can order it on Amazon. It's a small little thing. It comes with all of the gaskets, the O-rings, and instructions on how to open it, replace all of the gaskets, and suddenly you have a brand new pump. You understand what I'm saying? It's going to last you as long as you protect it. So in other words, it has this screen here, but you want to use more mesh around this to keep sand and sediment from coming into it. Because the more you screen the water down below, the longer this will last. You can have this thing last you 5 years before it gives you any problems. Or 6 months. Or 1 month, depending on how much you protect it. Because sand, dirt, grime, sediment is a pump's worst enemy. This pump, not so much, because it's more of like a mud pump or a trash pump, as they call it. But it still wears on it, and eventually it will go out. When this goes out, you chuck it and you go buy another one. You don't have another option. You know what I'm saying? It's basically nothing but a heavy paperweight. So, I'm talking to you about using solar in remote areas. So far, do you understand? Was this clear enough that, you know, it's not, I'm trying not to make it as complicated as possible, but it's very simple stuff. Hopefully, I'm going to try and hook something up today because I want you to see it in action. I'm going to hook this pump up so that you can see it pumping water from the ditch. Okay? Just so that you can see how simple it is. All of you can do this. You have no excuse after today for not knowing how to do this. You're not going to be experts, but you're definitely going to have the basic. And all of you have phones. All of you have YouTube. Instead of looking at the latest, I don't know, whatever it is you watch, the latest videos, the latest whatever, you could help your family by learning a little more about stuff like this. You know what I'm saying? And then you don't have a reason not to, But then I understand that not everyone can do this because there's not water everywhere. But that's fine. I'm going to talk to you about another portable solution that can be done. I know when I was in Monument Valley, a lot of the people out there, I was very surprised, did not have power or water running to their home site leases. And I was blown away. This was like in 2011 when I first started going to Monument Valley. And I was like, how do you survive? But then again, I'm not a city boy, but I have lived a lot in the city. Everywhere you live, you have power and water, right? At least so I thought. And then you come to the res and you're like, what's going on here? It's understandable once you start visiting these places and you're like, oh, that's why, because you live like in the middle of nowhere. And that's what they call home, right? And that's where people want to live. You can't dog them for that, right? That's where they want to be. And so, some of them can do this. Some of them have access to water. So not everybody does. So there's got to be other solutions. Anyways, I'm going to move on to something else. And eventually, when we're done this morning, I'm going to, we're going to do, probably in the afternoon for a short period of time, we're going to do a short demonstration. And I'm going to have some of you guys help me do some stuff. So, I'm going to put this guy aside, and I am going to bring you see this? What is this?
It's an illusion. Like when I look at it, I see black out. You know what I'm saying?
It's a little dirty. This is taller than me. Okay? It's very, very large. You can buy this panel for about 270 bucks. 275 bucks, I think, is what it's at right now. Does that seem like a lot of money? It does, but it isn't. It isn't. It really isn't. It's actually very affordable. Thank you. So, it's very affordable. It's less than $1 per watt. How many watts do you think this panel is capable of producing? Hey, that's a good guess, but no. Try 120 times 3. 360. 360 watts out of this one panel. My, can you believe that? Is that a lot of power? It is, but it isn't. You need a few of these in order to really be in business, right? Now, how much money do you pay in electricity a month? How much? 100? 100? Anybody else ever look at their utility bills? Okay. You know, my last utility bill in Oregon, I failed to pay 2 months, and then I had to pay it combined, was almost $800. Because depending on where you live depends on how expensive electricity is. So you're fortunate that you have 2 power plants here because it kind of helps offset some of that cost. You know what I'm saying? Yes, really. So, this panel here at $275, I would say is a steal. Why? Because you're paying how much a month? How long would it take you to pay this off? 2 months maybe? Well, what if you bought 10 of these? 20 months? How many is 10 of these? What's 10 times 360? 3,600? Is that a lot of power? It's definitely, you're getting up there. Now, what if you bought 20 of these? Now you have how much? Huh? 7,200? Yeah? 7,200 watts, right? 7,200 watts. And that would take you, at paying $100 or whatever, it would take you 40 months to pay off, not even 4 years. That's if you paid a minimal amount. You see where I'm getting? These are actually very cheap. And in the long run, this is going to save you so much money. Okay, why? Because you don't have to pay these people to give you power. You can make your own power, right? And then you can buy an electric car like me, and then you have free fuel. Yeah. So then you can say, I don't care about gas companies, I don't care about the electric company because... Okay, anyways, I'm not going to go there. But, so all I'm trying to tell you is it's affordable. Yeah, there's more to it than just the panels. I know. You have inverters, you have charge controllers, you have all the things you need to hold this down into place depending on how you set it up. But trust me, if you start slowly, and if you live in the middle of nowhere and you don't have power, you don't really have a choice. And it would be cheaper for you to do this. Okay? How long is this panel going to last? What do you think the warranty is on this? 25 years, yes. The warranty is 25 years. Does it mean it's going to last 25 years? You know, I know a lady who has a big solar array at her house. She's had them there for over 40 years and they're still producing electricity. They're old and ugly looking, but I mean, you know what? They still produce electricity, so who cares, right? So how nice would it be to literally live a good chunk of your life without paying utilities? Because, you know, you could buy electric stove, electric water heater, whatever. You know what I'm saying? But then you have the added cost of batteries and all this other stuff, which kind of gets old. So you really have to kind of choose how much money you want to spend and what you want to do, what you're willing to live with and live without. So this solar panel is more than enough power to power this little pump here. Okay? With just one of these, with half of this, you could power that. Okay? You wouldn't even need to spend $275. You could spend about $180, I think, for a smaller panel. Put it out there and pay another, you know, $400 for that pump with all the wires and stuff. That's pretty cheap, isn't it? Okay. Let's see here. Where do I put this? So now, talking about that same person that lives out in the middle of nowhere, or maybe you have a farm somewhere that you would love to have some power at, right? Wouldn't that be nice? I have something down here that you probably can't see, so you may have to stand up and come, or whatever. I have this little box here, and you might ask, what's in it? Pardon? Yeah, I'll have some guys help me. I'm just going to move all this stuff. Hold on, Javen. We're going to put it on top of this, Javen. Pick it. Here's my toolbox, guys. What do you think? Pretty secure? You think anybody would be able to break into this very easily? It'd be pretty hard, wouldn't it? What do you use stuff like this for? For what? What is it? Job Master chest. They make these in various sizes, right? Have you know, I think we have one over there. It's a lot bigger. They make huge ones. And it is for taking to a construction site, leaving it there so that you don't have to constantly haul tools back and forth like we do at the park, right? These things they're kind of expensive. I'm not going to lie to you. This little box right here was $400 at Frank's Supply. You don't have to buy this box. You could buy one from Lowe's or from Home Depot, a little larger, for $300. This is a 36-inch. The ones at Home Depot are 4 feet long, so they're even longer and they're a little wider. I chose this box because it's small and compact, and they didn't have the small compact one at Home Depot. Now, this box here, the reason I chose a box like this is because of its security. You can put a lock in here, and only you have access to this box. I intended on building this magnificent crate and stuff. I wanted to do it, but believe me, I just did not have time to do it. With the YCC program and several other things I had to take care of, I didn't do it as I wanted to do it. But nevertheless, I did something to kind of give you an idea of what you can do out in the middle of nowhere when you need power on the fly. Or if you just have a hogan out there and that's where you live. And what? I see you making faces. So you have a hogan out there and you just need a little power. This thing what's in here is enough to power a small house. Okay? So I'm going to open this. I want you to come up here and look at it. Okay. Don't be alarmed. It's just, it's not a coffin. So, it's kind of heavy. If you see inside of it, it's very simple. I haven't finished wiring it up, but I did make the braces for the batteries. You can see the batteries are braced in place to hold them in place so that you can literally haul this somewhere and it's not all going to be moving around. You understand what I mean? This is a 3,000 watt inverter. That's quite a lot of power. Okay? This inverter it has an outlet on this side. It has an outlet right here. But it also has a piece right here where you can hardwire it to a house or anything. Okay? And then if you look inside, I know all of you can't see it, but if you look inside of it, come up and actually look at it. I haven't finished it. It's still kind of a mess, but still, you can actually get a general idea of what it is I'm trying to do. So I have all these little components in here, okay? Inverter, batteries, charge controller, battery disconnect, an inline fuse for the battery, and then 2 breakers, okay? This is all that it takes to have power at your site, anywhere you want to have power, okay? So, to run this, to feed this, you would need 4 of these panels, okay? And you would need to mount them on something, and then feed the wire into this right here. This is a charge controller. I'm not sure what happened to the face. It was in here, but yeah, here it is. So this has a face. It's a digital metered face. I took it off because I was going to wire it, but then I ran out of time. Okay. So all of these components allow you to charge. And in a little bit, I'm going to explain to you the importance of this guy right here. Okay. You see this right here? It's supposed to have this face on it. The importance of this guy. You do not have to get something as expensive as this, but if you want to run 3,000 watts, you do. You can do something smaller. You could do, this is just to provide you enough power to last you through the night. Okay? It's not an elaborate, it's not something fancy, but it's something that will work. Now, where's those boxes? Brought some extra boxes. Maybe they're on that side. Yeah, those. So we have here, I haven't even opened this. So this is for a pump, but I'm going to get into something now I'm going to explain to you. Give me the other box that's back there too. Pardon? Okay. This is from a company in Arizona, Sun Pumps. This is meant specifically for, no, not that box. There's a cardboard box. Yeah, there's another cardboard box, smaller one, around here. Should be. Okay. So this right here is very similar to this. No, not turn it around. No, it's not that one. So this is very similar to this, okay? Why is this one so much smaller? Because this one can only handle 200 watts. Okay? So even that one panel is too much for this. Okay? You could get a 200 watt panel and run a pump like that, and you'd be in business. This thing is, and this thing, okay, so here's where I'll get to the cost difference. This right here is $700, almost. This right here is about 170. Okay? This is very simple. This has way more capabilities than this. This can handle 60 amps, far more power than this can. Now, why am I interested in telling you about this? Because this module here, like this one, does something with electricity to regulate how it stores power in your battery or how your load uses power. You can hook up this panel to that pump directly, and it's going to run, but it's not going to run efficiently because of how electricity works. Okay? So you can sit down if you want to. So if you were to just hook up a panel directly to a pump, right? If you were to do that, it wouldn't you have what's called and this is kind of getting a little complicated, but you have what's called maximum power transfer. Maximum power transfer. In order to have maximum power transfer, coming from this going to the load, the source and the load, you have to meet certain resistive values. So if I put this 360 watt panel on this pump, I'm only going to get about 120 watts or maybe even less at this pump from that panel. I'm not going to get 360, so it's not going to make this pump work any faster. Does that make sense? Let's say that the limiting factor is this 5 amp rating here, okay? And that's kind of the same thing on this solar panel. This solar panel, it has a sticker on the back, and it tells you what the current is. Short circuit current is almost 10 amps, but maximum power current is 9 1/4. And that actually means something. So this panel can put out almost 10 amps, almost twice as much as this can use. But the panel, because of this concept, that panel will not put out. Even if this pump was rated at 360 watts, if it only could handle 5 amps, it would not work, right? And it's because there's a difference in voltage and there's a difference in the resistive load. Okay? It's a lot of like math that to explain it. I'm just telling you. These things, this is a charge controller. What this does, it has basically, it converts that DC into AC using a transformer and electronics like I showed you earlier, and then it converts it back to DC. In other words, it's making the power usable so that you could theoretically get 360 watts to power this. Does that make sense? You might burn up the load because it's only rated for 120, but if this pump was rated for higher, then you wouldn't, obviously. And so that's the problem with solar panels in general. Even if you hook them up to your home, that's why you need things like this. Charge controllers like this, because this will optimize, or this, for a home, you want something at least this small, but usually they make them bigger for homes, for the larger power. It will optimize the power coming from the panels so that you're not wasting it. Because you see, the battery is doing the same thing. If it can't charge the battery equally at 360 watts, then you're going to waste a lot of panel. So you might think in your mind, oh, I only need to buy this and a battery. I don't need this other stuff. It's not going to work. Okay? There are things that you have to use in order to get maximum efficiency from what you're using. Okay? And that's all I really wanted to explain to you. So, does anyone have any questions about this? So, what might we use something like this for? Pardon? Camping? Power a house?
Well, how much is that?
So this is quite a lot of money. Okay? But remember, you would only have to buy it once. And it would last you almost forever, really. Okay? It literally would last you forever. And so here's another thing I didn't explain to you. When you came up here, you probably didn't notice this because maybe you don't really know the difference, but this battery here, the battery makes the system. If you buy a battery for your car and you put it in here, do you think it's going to work? It isn't. Because those batteries are not designed to hold a load. They're designed to just crank your engine at a high cranking current, and then they get drained really quickly. Okay? These are more like deep cycle batteries. They can take a charge longer. Now, even deep cycle batteries, have you ever heard of a marine battery? Deep cycle? Have you ever heard of deep cycle battery? Okay, so deep cycle batteries, you can buy them at AutoZone, and they're about $200 a pop. You put a deep cycle battery in here, you cannot discharge a battery to 100%. Like for instance on your phone. You know when you use your cell phone and it tells you you're at 100%, and then it goes down all day long until you're like, getting down to nothing, and then you're like, I gotta find power because I'm about to run out. Well, the reason is because those phones have what kind of batteries inside of them? Lithium. You've heard that before, right? Lithium batteries, have you heard of that? Like, for instance, these tools you guys used earlier in the week. So what kind of battery? If you had enough of them. What about this guy? What about this puppy? Lithium ion, right? You see it? This is lithium as well. So, power tools all use lithium. Laptops use lithium batteries. Your cell phones use lithium batteries. Why lithium? You know the batteries you buy, like the AA batteries that are inside these remote controllers? Or AAA, I think is what this is. Is it lithium? Look at it. What does it say? Alkaline. It's not lithium. Okay? What's the difference? What about the batteries in your car? What kind of batteries are those? They're lead acid batteries. They have acid inside of them. Right? Have you ever worked around a battery and got your clothes all messed up? Holes on your clothes and stuff? You want to know what it is? Sulfuric acid. Okay? It's pretty potent stuff. I wouldn't mess with it. So lithium is different. This battery in here, both of these are lithium batteries. So this battery has the ability to last 5 times longer than a regular lead acid battery. So these two batteries here are the equivalent of 10 regular batteries. Do you understand what I'm saying? Does that make sense? Because they have the ability to store far more power, but not just because of that, but because lithium, you can literally drain almost 100%. Whereas a lead acid, you can only go 50% or you'll ruin the battery. Okay? Lithium, more expensive, yes. But they are zero maintenance. You never have to do anything to them. Just keep them in a place that's not, super, super freezing or, exceedingly hot. And by that I mean like 180 degrees or something like that. I don't remember the exact temperature, but really, really hot, which none of that exists here. Lead acid batteries require a lot of maintenance. You gotta put water in them. Have you ever heard of putting water in your battery because maybe the water evaporated? If you haven't, you'll learn about it at some point in your life. You know how you ever look on the batteries in your car and they have those little tops you can lift up? And then you see those holes? Usually they have 6 of them because there's 2, 4, 6, 8, 10, 12. Each cell is 2 volts. Okay? This you never have to do that with. And the final thing that makes lithium better is that lithium batteries do not produce gas like lead acid does. When you put lead acid battery in an enclosed container like this, it produces hydrogen gas. You know what's the problem with hydrogen gas? It's explosive. And then if you have electronics in here that are creating little tiny sparks, it's a ticking time bomb. You know what I'm saying? So if you do this, do not ever put a lead acid battery in here with the inverter. Ever. Ever, 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 ever. Don't do that. It's a big no-no. You will regret it. A lithium battery is okay because a lithium battery doesn't produce gas. Does that make sense? It's basically that simple. So, any questions about that?